Hi everyone, welcome to this session on GraphQL APIs. As you know, this is the 10th session in our API series. In the previous session, we had covered REST APIs in detail, and in this one, we'll get familiarized with GraphQL APIs. So this is our agenda for today. First, we will start by understanding what GraphQL is and then compare it with REST APIs so that we can clearly see the differences between these two and where each one fits best. Then we will dive into authorization of GraphQL APIs and see what GraphQL Schema is. From there, we will look into how to enable GraphQL APIs for your profile so that you can start using them. We will look into GraphQL queries and how introspection helps us understand what is available in your schema. We'll also explore Postman Schema Explorer to help us build queries visually, and we will practice filtering, ordering, and paginating responses of GraphQL APIs. After we have got all these foundations right, we will check a business need and fetch data for a dashboard for Silker support system. Finally, we will see in detail about credits, complexity, and depth concepts of GraphQL APIs. What is GraphQL APIs? GraphQL stands for Graph Query Language. It's a query language for APIs. Using GraphQL, you can request for the exact data that you need using a single endpoint. Now let's compare REST APIs and GraphQL APIs. Both REST and GraphQL send HTTP requests and return responses in a JSON format. For REST APIs, each resource has its own endpoint and it works best for straightforward use cases such as fetching or updating a single record. For GraphQL APIs, all data is accessed through a single endpoint, and it is beneficial when you need related data from multiple modules, whether they may be accounts, contacts, or deals, in one go. With a single query, you can exactly fetch the fields in a unified response and get the response without making multiple API calls. Now let us check GraphQL authorization. GraphQL uses OAuth 2.0 for authorization, same as that of REST APIs. This is the industry standard for authorization, and you use the same secure process to get an access token that you would do for REST APIs. This ensures secure token-based authentication for every single query, guaranteeing that only application authorized with proper scope can access your data. Similar to REST API, it fully enforces role-based security. The GraphQL API doesn't bypass your Zoho CRM's permissions, it respects them completely. So what does this mean in practice? If a user in your Zoho CRM doesn't have permissions to see the deals module's content, any GraphQL query they run, no matter how cleverly it is written, will not return deal data. GraphQL Schema. What is GraphQL Schema? Think of schema as a contract between the client and the server. It clearly defines what kind of data is available and what operations can be performed on the data. The possible operations in a GraphQL schema are queries to get data from the server, mutations to change data, subscriptions to get updates in real time for subscribed clients. As of now, in Zoho CRM, we support query operation. This means you can use GraphQL APIs to fetch data. Types. So types form the building block of schema, and they specify data, its relations, and its structure. In Zoho CRM, query exposes two fields, meta and records. Let us see this in Postman. So here I am authorizing GraphQL APIs using client credential method. Here I have the schema. So the schema is loading here in Postman. So you can see that query is the entry point And inside query, we have meta and records. Meta is of type underscore meta and records is of type underscore records. Before you start using GraphQL APIs, you need to enable GraphQL for your Zoho CRM profile. This needs to be done once for each profile in Zoho CRM. Here is the request. It is a post request to the endpoint crm/GraphQL/enable. You need the scope Zoho crm.graphql.update to make this API call. If GraphQL APIs are not enabled for your Zoho CRM profile and you try to use them, you will receive a feature not enabled error. So how do we call a GraphQL query? So the request URL is post method and crm/GraphQL. For access, you will need Zoho crm.graphql.read scope, which allows read access through GraphQL APIs. You also need the scope of the resource that you are querying. For example, if you are fetching contacts, you will need contacts read scope in addition to the GraphQL read scope. GraphQL Introspection. GraphQL Introspection is one of the most powerful features of GraphQL. Unlike REST, where you usually need external documentation, GraphQL APIs are self-discoverable. Clients can query APIs to know about the resources, the fields inside different resources, and the relations between the resources. GraphQL APIs makes it easy to explore the structure of the data available, and it makes GraphQL developer friendly and self-documenting. Postman Schema Explorer acts as an interactive visual query editor. This comes in handy and it helps us visually navigate the GraphQL schema. You can explore the fields and select what you need, and as you select them, Postman automatically helps you build the query in the query editor. This makes working with GraphQL easier, especially when you are new or you want to deal with a complex query. So let us see this in Postman. So this is our Postman Schema Explorer that we already saw. So this is the entry point, and we have meta and records. Meta for fetching the metadata and records for fetching the data inside the different modules. So this is a simple GraphQL query to fetch the email and city of leads. So here inside records, I can select leads and data. So as of now, I have email and city. So email is selected here and city. You can see that city and email are of string values. This means that they are objects that contain value of strings. So value is where the actual data is there. So when we fetch data, we will have the value of email inside email value and city inside city value. Here, as I already told you, we can see this gray colored are the types. And inside here, we have the scope required for this resource, the complexity, and the credits required for fetching the resource. We will see this in detail. Inside modules, data, we have the different kinds of metadata of modules like plural label, ID, properties, etc. So here we have one of module type, that is the parent module of this module. So in this case also, the scope required and the complexity and credits are mentioned. Inside records, we have contacts X campaigns. As many of you might already know, this is a cross-module relationship. Here, products module is of type products underscore connection. This means it is a paginated connection, which is a GraphQL standard, means the results returned from the products module are paginated. So we have leads module here, and here there is a related list label, and it has the suffix underscore underscore r. This usually means that it is a related records of the module. Some types in GraphQL schema in Zoho CRM are available in the response only when a single record is fetched. Let us see such an example. Here we have a query that fetches module metadata, and I am trying to fetch the layout of module metadata. Let me show you it in the schema explorer. Here in meta modules, I have data, and inside here I have layouts. Note that it is marked as single. This is a custom directive in Zoho CRM GraphQL schema. So let me execute this query and see what happens. So I have the different data such as plural label, submenu ID that I have requested here available, and also but other fields, but layout is getting returned as null. So here there is a warning that mandatory arguments are missing for the layout, and this means that only when I fetch a single layout using the layout API name filter, which we will see in upcoming slides, the layout data will get fetched. So here I have modified the query by using the filter. 1 minute. So here inside modules data, so filter API name, I'm giving as lead. So let's see what happens. You can see that as I typed here, it got changed in the query editor. Sorry, let me give it here. So API name as leads here. So as you can see here, the different, I am fetching a single API name here. Earlier I was fetching two modules. So this time I'm fetching a single API of leads. And then here we have the details of layouts available in the response. So how do we filter responses for different queries? So when we want to filter responses, we use the where clause to filter responses, and the type that have the arguments that can be filtered is defined in this format, module underscore filter. So let us see this here. So here this query fetches a single contact. So if I want to filter the contacts, here I am using the where clause. I have given the where clause as last name like D and phone number equal to this one, or mobile like 5%. That means the mobile number should contain 5. We use it for pattern matching. So here, when we see inside records, contacts, and data, records, and inside where clause, you can see that module underscore filter type argument is present, which gives us the options of different fields. So these are the arguments that we can pass, and we can use it to filter the response according to our need. So GraphQL offers a rich set of operators for precise queries. You can compare using equals, not equals, greater than, less than. You can do pattern matching using percentage as a wildcard and not underscore like. And for fetching from list, you can use in or not in operators. So let us see paginating responses now. You can use offset and limit arguments for pagination. When you send a query, you can ask for details of the info object, which will contain the details required for pagination, such as next offset, more records, and previous offset, etc. So let us see this. So here in this query, I am limiting the number of records fetched by using the limit argument. So let's see what happens. So here I have 10 records from the contacts module fetched. So how do I know whether I have more details or not in this contacts module? For that, we pass the info object. So here inside, we have data and info. So we'll pass the info here. And in that, I'll get next offset, previous offset, and more records, which we can use for pagination. So here I have next offset. So using this offset value, I can it in the query and get the next set of results. So here I have offset value passed. So we will get the next set of details. So here we have the next set of details. Even though I have given limit 5, there are only 2 records present. So I am getting records 2 and more records value is also returning false. That means no more records are present for the contacts module. And if we want to fetch the previous page, we can use the previous offset by passing this offset value. So how do we order responses for records? You can order response for records by using the order by clauses. Order by type argument defines which fields can be used for ordering response for records. We use the order by clause. So you can see the order by clause here, and in the schema explorer we can see the different arguments by which we can give the order by response. So here I am giving order by ID, and I can give the order as ascending or descending. So here in the query part, I have contacts order by ID ascending. So let us execute this. Let me fetch the ID also. So I have the response in ascending order of ID here. So that's how we order the response. So next, let us see filtering response for metadata. Filtering response for metadata is a little bit different from filtering response for records. So here we have the where clause for metadata for records, but for metadata we have the filter argument. So inside the filter argument, you can pass the API name. So here I am giving filter as API name leads. For filter it for API name leads. So when I execute it, I get the response only for leads module metadata. Let me show it to you here also. So inside records modules, you have the filter argument, and the different arguments that are available for filtering are shown here. So this is module filter type for modules. For users, we have user filter type. Each resource will have separate set of arguments for filtering. You can either refer the document, or you can use Schema Explorer to see which all arguments are available for filtering. So here I'm giving module name as contacts type and asking for all the data. So we have all the details of contact modules metadata here in the response. So now we have covered all the fundamentals. Now we will go through a business case of Silka manufacturing. Silka is a large-scale industrial equipment manufacturer, and their sales team uses Zoho CRM, but the support team uses a legacy system. So they are facing a challenge that when a customer calls, a support agent is usually switching between different screens to get all the data they need. They might need, for example, the details of the contact that is contacting them, like phone, email, and account information, the ongoing deals of the contact, such as pipeline stage, expected revenue, deal name, etc. So because of the switching between different screens to get the required data, the response time is getting more and customer experience is not very smooth. So they are looking to design a dashboard that will have all this information together, and so that they can quickly refer it during a customer call. So how will we usually do it using REST APIs? We will make one call to Contacts API to fetch the customer's details and another call to the related record to get the deals. We also need additional information to Modules and Fields API for getting the metadata to know how to label and display the fields properly. So if we are using GraphQL, this can be done in a single request and you will get a unified response and have exactly what you need. There is no underfetching of data or no overfetching of data. This means you don't get less data than what you need or you don't get more data than what you need. So let us see how to do this. So first, they need the details from contacts module. For that, they are calling query records, and inside records, they have applied a filter and given the argument as email and gave the customer's email ID. So they also want the full name, and inside contacts, they have the deals related record. For deals, they are fetching the expected revenue, deal name, and stage. These are all the data required: email, full name, and inside deals related record, expected revenue, deal name, and stage of the deal. So we have all this detail. So now we need details of both contacts metadata and deals metadata. So let us try to fetch both contacts and deals metadata. So here I have applied the filter meta modules, and inside filter I have given API names as contacts and deals. Inside data I want fields of both these modules. So I have selected data as API name and display label and data type. So here is the catch: you can't get the fields data here because it has single directive. We saw this case in layouts earlier. So if we fetch it, we won't get fields detail. So for fetching both the module metadata of contacts and details, we can use an alias. So here I have marked contact metadata meta with the alias contact_meta, and this lets us fetch the details of contacts module alone. So here I have given contacts, and let me click on send. So we have the details in the response. So as you can see, field details are fetched this time. So you might think, want the deals metadata as well. We give contact metadata inside contact underscore meta alias and deals meta underscore deal in deals underscore meta. So when I click on send, here I have the data and deal related record data, contact metadata and the fields of contact module, deals metadata, and the details of the deals module. So this is all the information that we required for the dashboard for our support agents. So now let us look at credits, complexity, and depth of GraphQL APIs. So credits, for the, I'm sure all of you are familiar with REST APIs. So similar to REST APIs, GraphQL APIs also consume credits, and a single GraphQL APIs can consume up to 10 credits. So how this is calculated is that as the different resources are queried inside GraphQL, all these credits get added up and they are rounded off to the next integer. So beyond credits, we also have query complexity. Complexity means how much load a query can put on the server. The maximum allowed complexity for a GraphQL API is 1000. For example, a root level query may cost 100 points and each parent lookup can add 25 points. So let us check this here. So we have the details here, scope and complexity. So when we get into the root level itself, it is complexity is 100. And this is a parent lookup which adds 50 complexity. So like this, when we select each resources, the complexity gets added up, and the total complexity cannot exceed 1000 for a single query. So if it goes beyond this threshold, you will get execution aborted error. Then there is query depth. This means the number of nesting level of a field. The maximum allowed query depth is 7 for metadata and 3 for records. So this is what we mean by query depth. We count it like this: first depth 1, depth 2, and inside data for parent module depth 3, like that. So in short, credits control how much resource you can query at once. Complexity ensures that the server is not overloaded, and depth means the nesting layer of data in your GraphQL APIs. To conclude today's session, we have seen how GraphQL opens up a new way of working with Zoho CRM data, and unlike REST, where you need multiple API calls to fetch the data you need, GraphQL gives you exactly the data you need and nothing more and nothing less in a single and efficient query. We have also explored how schemas work and how queries from both metadata and data can combine together. Through Silka Manufacturing's example, we saw a query for real business value. We also explored Postman Schema Explorer, which makes it easier to learn. So in short, GraphQL APIs build faster, smarter, and more adaptive system for Zoho CRM.